Session. So this is session number 4 from Probability Standard 11. This is presented by S. Murugayan from EDUCARETAKER, Chennai. In the last 3 sessions, we have discussed 18 questions from the exercise 16.3. So let us start our discussion from question number 19 of the same exercise 16.3. Question number 19. In an entrance test that is graded on the basis of 2 examination. In an entrance test that is graded on the basis of 2 examination, the probability of randomly chosen student and passing the first examination is 0.8, and the probability of passing the second examination 0.7. The probability of passing at least one of them is 0.95. What is the probability of passing both? It's a normal question. If we concentrate solution part of this question, and 2 examination 1 can be taken E1, examination and 2 can be taken E2. So probability to pass the first examination E1, P of E1, probability of passing second examination and E2. So let us take E1, event of passing examination 1. And E2, event of passing examination 2. That is second examination. Okay. And what is given from the data? Probability to pass the first examination denoted by P of E1 is 0.8, and probability to pass the second examination, it is P of E2, 0.7, and probability to pass at least one of them, that is P of E1 union E2, is 0.95. Let us apply addition theorem. Applying addition theorem. Theorem of probability, and P of E1 union E2, this regular formula, P of E1 plus P of E2 minus P of E1 intersection E2. But we need what is the probability of passing 2 examination simultaneously, 2 examination. So P of E1 intersection E2 is required one. Then P of E1 intersection E2 will be equal to P of E1 plus P of E2 minus P of E1 union E2. Okay, P of E1 and 0.8 and P of E2 0.7, P of E1 union E2 0.95. So 0.8 and 80 plus 70, that is 1.5, and we have to subtract now 0.95. If we subtract 0.95, then 10, 5 and 14, 5, it is 0.55, 0.55. So this is the required answer. And go through this, we'll move to question number 20 now. 20th question, the probability that a student will pass the final examination in both English and Hindi is 0.5, and the probability of passing neither is, that is, probability to pass neither English nor Hindi is 0.1. If the probability of passing the English examination 0.75, then what will be the probability of passing Hindi examination? So let us concentrate first the data available. The probability that the student will pass the final examination in English and Hindi, that is, we can take an P of E union H. Here E stands for and passing English examination, and H stands for passing Hindi examination, and E union H mean and probability to pass at least final, at least, that is, pass the final examination both English and Hindi, and probability of passing English. So at least is not given. English and this should be intersection 0.5. It is given, and probability of neither, that is P of A complement intersection B complement, is 0.1, and probability to pass the English examination P of E 0.75. Dear student, from the data it is known that and P of E union H is nothing but 1 minus P of neither A nor B is at least. So 1 minus 0.1 is nothing but 0.90. It is P of E union H. Now we can expand using addition theorem P of E union H, and P of E union H equal to P of E plus P of H minus P of E intersection H. All data is available except P of H. P of E union H equal to 0.90. P of E is given 0.75, and P of H to be estimated, and P of E intersection H is given 0.5, and this implies 0.90, 0.75 minus 0.5 and 0.25 plus P of H, and this implies probability to pass in the Hindi examination 0.90 minus 0.25, so 0.65. So that 0.65 plus 0.25 will be equal to 0.90. So this is the answer. And go through. We'll go to the next question now. Question number 21. In a class of 60 students and 30 opted for NCC and 32 opted for NSS and 24 opted for both NCC and NSS. If one of these students is selected at random, find the probability that subdivision 1 the student opted for NCC or NSS. The second one, the student has opted neither NCC nor NSS. Third one, the student has opted NSS but not NCC. This is really nice question. So how to plan? Let A be an event of opting and NSS by a student. Okay, and from the entire lot of 60 students, and B, even B an event of opting NSS by a student. Okay, then N of A, that is N of S, from the data N of S sample points overall 60 students, N of A total number of students opted for NCC 30 students, and N of B total number of students opted for NCC 32 students, and N of A intersection B opted for both NSS and NCC. There are 24 students out of and 60. These are the available data. The student opted for NCC or NSS probability. So subdivision 1 and probability of the student opted for NCC or NSS mean A union B. Either A or B opted for either NCC or NSS. That is P of A union B. Addition theorem saying P of A plus P of B minus P of A intersection B. P of A, there is 30 out of 60. P of B, 32 out of 60. P of A intersection B, 24 out of 60. So 30 minus 24, 6 plus 32, 36. So 36 out of 30 are P of A union B after simplification, and 6 by 10 or 6 by 10. We cancel, or if we simplify by 6 table, 6 into 6, 36, 10, that is 3 by 5. This is subdivision 1. Now let us move to subdivision 2. And second subdivision, the student has opted neither NCC and nor NSS. That is P of neither NCC A complement intersection nor and NSS B complement. And from familiar formula, this is 1 minus P of and A union B. And P of A union B 3 by 5 is 1 minus 3 by 5 and 2 by 5. Okay, this is 3 by 5. This other one is 2 by 5. And third one, the student has opted NSS but not NCC. Is opted for NSS but not NCC mean P of is opted for NSS. NSS mean B, opted for B but not for an NCC, A complement. Okay, so this is nothing but P of only B. How to get it? P of from P of B, we have to subtract the common P of A intersection B. What is P of B? And P of B equal to 32 by 60 and P of A intersection B, then A intersection B 24 by 60. So 30 minus 24, 6 plus 2, 8. So 8 by 60 means 4 by 30 and 2 by 15. Clear? 32 by 24 and 30 minus 24, 6 plus 2, 8 by 60, then 4 by 30, finally 2 by 15. Finally 2 by 15. So this is the final answer. So dear student, this is the last question of the exercise 16.3. Let us wind up this session with question number 21. We will continue in the next session miscellaneous examples and miscellaneous exercise. Thank you students. So this is presented by N.S. Murugayan from EDUCARETAKER and Chennai. Thank you.